Let me know if the feed is good.
I hear you much better now.
Okay. But is it echo though?
No echo.
No echo? Okay. All right, cool guys. This is John. Can you hear me?
Yeah, I can hear you.
All right, cool guys. So let's start this workshop, guys. So I can give you a quick background on myself. So, hey, it's Jahan Saib. People call me Jay. I'm developer relations advocate in Coreum. So I'm gonna be explaining the smart contract side, smart contract side, and the goal for today is to build a DAO contract, and we also have front end and back end integration as well. So you guys can actually create proposals. You guys can vote on proposals. In future, we're gonna obviously we're gonna have our own like a website where you can able to create proposals, actually vote, and any kind of workshops you guys want to have in future. If any idea you guys have, obviously you guys can have that as well. And so yeah, guys, John, if you guys, John, if you want to give a quick intro.
Yeah, no, sure. So my name's John. I'm also DevRel at Corium, and yeah, I'm going to be working with Jay to give you this workshop on how to set up your own DAO, and then how to integrate that DAO into the TypeScript UI. And yeah, it should be really fun, and we hope to make this a project that as Jay said, that we you can all go to and kind of vote on what workshops you'd like to see us do in the future.
Cool, cool, cool. All right, cool guys. So let's start with this workshop. So as you guys know, this is like a Cosm Vasm smart contracts, and so we have like four file or five actually. One, yeah. So we have like contract Rust, we have like error, we have library, we have message and state. So we already have created contract because this workshop is gonna be a little bit too much because we have like front end and back end as well. So that's why. So I can just quickly can show you what's going on with this contract, and then later John is going to be sharing his screen and explaining you the front end and back end side. All right, cool guys. So let's start with this workshop, and so I will be explaining you the Cosm Wasm smart contract side. So we have like four files right now, as you guys can see. Contract, we have error, we have library, we have message and state. So contract. So this contract is basically our main file. That's where the our function and logic is. And then we have errors that I will show you that how actually I'm actually importing in the contract. And this is the library that where I'm actually basically just all importing all the different files, for example, contract, messages, state, and error. And then we have a another one which is messages. So these are all messages that we have right now. So basically, this file defines the messages that contract can accept. So this contract I'm talking about. So later on, I'm going to show you how actually I'm communicating with this file. And then we have another file which is called states. This is states functions. I mean, not functions, but we all have states here. We have like a proposal structure base. Within this structure, we have ID, title, description, recipient, amount, votes for, and votes against. And I'm just giving basically a type, like type of title should be string, same for description, and recipient should be address, and basic all like structure. I think it's really simple. That's all the details that I'm talking about. And just to give you a little bit context on this site, so this one is basically a hash set. So what Heshet is basically designed to store items such that each item is unique, it cannot be duplicated, and that's why we have voters. So for example, if you have address, if you're voting on a proposal, so you cannot propose twice. So if, for example, if you have like a same address, so this hash set which basically is going to say, oh, this address has been duplicated, and that's why we're using hash set here. And then we have executed thing for boolean mean, which is going to be true or false, whether this proposal has been executed or not. And then we have a voting time. I think this is very basic, like a basic structure. Structure is like a data structure proposal. We're basically storing every kind of details. And then we have a member. So member obviously is going to be you, where we're going to have address. Obviously, we have address type right here, and we have unassigned 128. And so we can have 128 bits right here for weight. And then we have two things right here. We have proposals and members. So guys, map, if you guys are coming from Solidity or EVM side, so if you guys can remember, there's something called mapping in Solidity, right? So we're gonna have key and value, and we're gonna explain, okay, what this mapping is, right? So it's exactly what we're doing right here. We're importing this map, right? And then we are having this is a key. So I can show you, this is like a key unassigned is basically our key, and this proposal, basically this struct proposal is going to be our value, if you can see right here. So whatever ID or key you guys have, that will be actually going to be returning a proposal, right? It's going to be returning a value, and we're just basically creating a new instance right here, and we're just saying that this mapping is going to be like proposals. Okay. And then we have same for members. So members, we have key and we have values, and key we have address, and then we have member as well. So member is basically this is the member. For example, if you have address, and then it's going to be giving this member value, and we're basically creating a new mapping here. And yeah, that's the states. Later on, I'm going to be showing you how we're actually implementing on the contract side. And yeah, guys, let's go to the messages. So the message is actually important as well for us. So these are the messages that I'm basically using. I'm actually importing member and proposal from the state side, and then I'm also having like these query responses and search. So I'm going to explain you what that is. Don't worry about that. And we have two things right now. We have address and unassigned that I'm importing from Cosm Basm STD module. If you guys want to click this, go to the definition, and it has like tons of different things that you guys want to use. But in our case, we're gonna be importing address and unassigned 128. And yeah, so we have three things right here, guys. We have struct, which is basically instantiating the message. Within instantiating message, we have like a member, and we have a vector. So what vector means is basically it's like a dynamic array. Within dynamic array, we're actually giving a type of member. So as you guys can see, if you guys remember that I'm actually importing this state uh, into this Rust file, and then I'm actually giving a type of this member to this vector array. So now this members will be allocated as vector in a member format. I mean, in just like a members. So that's what that struct and instantiate message means. And then we have something else. We have like execute message. That's for execution purpose. Later on, John is going to show you how we're going to be executing the messages on front end and back end side. So we have three things right here, guys. We have propose, we have vote, and we're going to have execute. So in propose, we have title, description, recipient, and amount. So how that's gonna work is basically in a return format. Now John is gonna show you how his return format actually works on the front end and back end side. So that's how basically it's gonna return. So I'm just showing you an example how it's gonna work. So we're gonna have title, and within title we're gonna have like something like this, and it's gonna be a string format. Same for description, and same, that's basically a returned format on the front end and back end side, guys. So yeah, and this is for propose, and this is for vote. That we have a vote. You obviously, when you're voting, you're going to be voting on a proposal ID, and now proposal can be approved, sorry, vote can be approved or it could be not approved. Same for execute. So for when you're executing, It's gonna be execution happening. I mean, you're gonna be executing a proposal ID. So this is basically really simple. You know, if you so that's what that means, guys. If you guys have any do you guys have any questions or any concerns right now? Any John, if these guys have any questions regarding anything?
Sure, sure. Let me check real quick.
Yes, please. If you
Um,
guys have any questions, let me know. It's all good.
let's see. I don't see any questions.
Okay, so
Mm,
that means we don't got any questions. That's perfect. That's perfect. That's cool. And all right, let's start. Yeah, let me just continue. If you have any questions, guys, please ping me and obviously John as well. I mean, in the chat, uh, we can give you answer. No worries. All right, cool. And then we have something else. Okay, now we're gonna go ahead and I'm gonna explain you what this enum um, messages means. So this enum, guys, this is like for acquiring the messages. Okay, so this is like acquiring messages. We have a proposal to get proposal. We have list proposals. We have get members. We have list members. So yeah, that's what that enum is. So if you guys don't know what CERT is, so this is kind of like a, I would say, in if you guys know Python, so in Python we use decorators, but here we're actually using macros. So these are like macros, and then we are using CWSert is like for serialization and deserialization purpose. It's like a it basically allows for converting data structures to and from formats such as JSON and YAML, BSEN, and many others. Basically, that's what that means. And this is basically for acquiring responses. If you guys want to click this is a function that I'm actually using. If you guys can see right here, this is like a macro that I'm actually just putting into the message. And and yeah, guys, this is like a get proposal. But then we are returns proposal. We have list proposal. That's got list proposal, and we have get member, and then we have list members. So this is basically file for messages, and then we're gonna go to library. So library is basically really simple, where we actually importing all the files, for example, contract, messages, state, and error. And then let's go to the error file real quick. So this is basically we're actually giving all the errors. So within this error, we have unauthorized error, we have like invalid input, we have already executed error, we have proposal, we have insufficient funds, we have member already voted. So these are all the errors that we're gonna be using later on the main logic file, which is contract.rust. And yeah, we're just basically importing the necessary libraries, which is error and standard error. And that's what all these errors we're basically just importing. Okay, guys. All right, cool. So now we can go to the contract.rust. So within this contract.rust, we are importing actually tons of different things. So bear with me, guys. If you guys don't know what's going on, it's okay. So let's see what's going on with this. This is like a main logic, main contract for our DAO contract. So basically, we are importing hash set. As I explained you, hash set is designed to store items. That each item in set is unique, and you cannot duplicate the items to a hash set. And if you are duplicating that hash set will be actually gonna ignore that. So that's what that means. And we're importing all the necessary things from Cosmosm standard library, entry point, JSON address. Address basically just an address that we're human readable address, and we have bank message. So this is basically for send and burn. It's like a Cosm as a module. I mean, that we're gonna be later on. I'm gonna show you what we're doing, and then we have like coin. Is basically I can show you what that is. It's basically denum and amount, and this is dependencies, and this is like dependence mutable. So dependencies basically provide access to this blockchain state, and it's basically like primarily is like interface through which the contract interacts with blockchain specific functionalities. Later on, I'm going to explain, don't worry guys. I'm going to show you what that means. And then we have a message info, we have env, we're importing basically. It's like an environment, So for from the blockchain, and is that's what that means. And these are all the so we're actually importing execute message, instantiate message, and query message from the message. Uh, uh, just what I showed you guys. So I can go you message. Okay, this is the message file right here, and that's what we are importing. So that's how we actually import in Rust, guys. So you basically see a crate, and we use double colons, and then we use message, and then we obviously have like a curly braces, and then you can basically can import whatever things you want. For example, execute message, instantiate, inquiry message. Go there and basically just import whatever you guys want to do. So here I have actually imported execute instantiate inquiry proposals, and same for state guides. I have imported member proposals. I could show you just one more really real quick time. So right here is proposal member proposals members. That's what I'm literally importing right now right here. So that's what's happening. Any questions, John?
Let me check real quick.
Okay.
Uh, nope, we have no questions.
Okay, no questions. Cool. All right, cool. So yeah, guys. So now let's quickly go to the contract side. So this is basically a const denom and page limit. So with this denom, so what I'm doing right here, I'm saying const. Basically, it's a constant, and this is denom. You can call it, but you cannot update this string. So this is basically we're using utest score, and I'm actually giving a type of this denom to string. So this and refers to, guys, is a reference that I'm actually taking a reference of this string. So what that means is reference refers to a logic that there's something there's a concept in Rust we call is borrowing concepts, cloning concept, and reference concept. That's where the concept comes from. I would suggest you guys to please go ahead and learn this if you guys don't know. So I'm actually here taking a reference for the string, and I'm actually passing in utest core. All right, guys, and then we have max page limit that could be a type of unassigned 32, and then we have 250 for queries. Okay, so that's what we have right now, and then we have a main function, which is basically like an entry point function. So this is called an instantiate function, and within this instantiate function, we have a parameters of dependencies. So I'm passing dependencies as a dependency mutable. So what that means is I can actually can update those dependencies if I want to. That's what the mutable thing means. I have to specify. I have to give this type of mutable. And then we have env. Within env, we're actually, as I told you, what env is. It basically stands for environment, and this is like a contextual information from the blockchain itself. And yeah, that's what that means. And then we have a info. So this info, we're giving a type of message info, guys. And when I click this message info, and I can, if you guys can see right here, this is like a struct. We have sender, we have funds, and that's what we have right now. And then we have message, and I'm giving a type of instantiate message that I'm actually importing from the message. Cool, guys. And yeah, that's what that instantiate parameters is. And I'm actually saying when this function, what that means is basically I given all these parameters. Once it's done, then I'm actually going to be returning a standard result, and I'm actually going to be returning a response. So I'm gonna explain you what that means, guys. Don't worry. I'm gonna explain what that response is. I'm actually gonna be This function is actually gonna be returning a response, same as in TypeScript, where you have to give colons to functions and then explain, okay, are we returning bool, or are we returning any kind of different things? Same in Solidity. If you guys want to return anything, you're gonna say returns, put the format, whatever the format is. Same in Rust, we are actually returning response. And then we have a set contract version, guys. Within set contract version, we have a lot of stuff. We have dependent storage, we have contract name, contract version. You always have to do that. You have to set your contract version. So what that means is depth storage refers to a is basically like a local storage where WASM contracts have their own isolated storage space where they can read and write data. and that's where we're putting right here. And then when we're setting up the contract version, we have to give obviously the contract name, and obviously we have to give out the contract version, and then we're just giving a question mark. So the question mark, what that means is question mark is basically like an operator. It's like an error operator. If this doesn't work out, then obviously we're gonna have this question mark, and it's gonna return the question mark to us, which is going to be error, returning error. Okay, and obviously you guys have to give a semicolon. If I don't, there's going to be error. And then we have like we're basically now iterating through the messages. So we have message, and then we have instantiate message. So this is like a message dot members, because obviously we're importing it. So I can show you this instantiate message really quick time. So we have members, that's where we're accessing right here, and we are iterating through those members, and we are saving the members as I showed you right here. This is a key value. This is like a mapping. That's where we are storing, guys. We're storing the members, and now we're putting storage. We're putting the API. So dApps. This is like a storage that I just literally just told you that it means it's like a local storage where you can read and write data. Okay, that basically we can get the data from, but now we are actually saving our members to the storage. Okay, this dependency storage, and then we are saying dependency.api. So this means is basically this provide access to blockchain specific APIs that are not directly related to state storage, such as functions, addresses, or to query other smart contracts. So this basically API is going to help you in transferring data types. So that's what that means. And now we're gonna say, okay, please validate the addresses so that you guys can vote. If I'm not gonna put this address validate, so it's not gonna validate the member for us. For it's not gonna validate any kind of member address or anything like that. And here we're basically literally this is like a function that we're accessing. I can show you real quick what that means. This function we're returning the address. Within this, we have like a human member, and we're saying this member is going to be address, and we're just converting it to a string, and obviously it's same for question mark. And yeah, guys, and that's what we have. And here we have also another stuff where we're going to be saving, which is member, which I literally showed you is in a state. You guys can see right here we have address and weights, and then we're just using a reference. We're taking a reference for this member, and and then we're just putting the addresses. We have to obviously explain what kind of address it is, which is member dot address dot clone. And once we are done iterating and obviously saving those members into a dependency storage and validating, once the validation is already happened, then what we're gonna do is we're gonna be firing up those events. So this is basically how we fire up the events. This is like an event structure, because we are returning okay and standard results. So within this, now we have an axis of okay. So within this okay, we have response of new, and this is basically we are creating a new attribute, which means is basically it's like an event for action, and then we are giving a value of instantiate. So that's what that okay means. Okay. And then later on, let's go to the execute function. Same execute, we're gonna have same parameters execute, but right now here we're using instantiate message, but right now we're gonna be using execute message. I could show you what that means. So this execute message refers to propose, vote, and execute. And then we have, so now what we're doing is we're gonna be returning response or in a contract error. That's what that means. We're basically, this function is gonna be returning a response or a contract error. Okay, so in Rust, guys, we have something called match statement. It's kind of like a if-else statement, or you guys can see, but it's like it's like a conditional. Okay, so what that means is, for example, when what's gonna happen is, because now we are actually inheriting or basically giving a type of execute message, and we're saying match this parameter message. Okay, within this message we are gonna say if the execute message, if you're proposing these details, we're gonna be actually gonna be returning execute propose. So this execute propose is basically this function that we're gonna be returning. For example, if you guys gonna propose, this message will be is going to be matched, and that's what's gonna return. If you guys gonna vote, that's what's gonna happen. You guys gonna basically return a execute vote, and we're gonna have proposal ID, we're gonna have approve, and within this we're gonna have execute vote, and within this we're gonna have execute message, and we're gonna execute the proposal ID, and we're gonna be returning a execute function. Okay. Now let's see what these all function means. We can go execute propose. We all have parameters for this for all these that we want from for our proposal basically. And same, we're turning a result response contract. We have a voting period which is 120. 120 refers to 2 minutes, and basically this is in seconds, so we have like 2 minutes, which is 60/60, which is basically 120. So we have to specify. That's how Rust or Cosm as a smart contract is gonna understand. We cannot say 2 minutes. We have to specify in a number format like this, right? So we're saying 2 minutes, so that means it's 120 seconds for voting period. Here we're actually going to be giving a proposal. They have to give the details of all proposals right here, guys, because this is executing propose. And now you guys can give every information here, and then we are saving all the proposal details, and we're going to be response we're going to be firing up the event for this particular messages. Then we have execute vote. So I will just explain you till execute, and then John, you can start explaining the front end and back end. All right, cool.
Yes, sounds good.
All right, cool. This is basically, guys, for voting function. Where we have is basically we have same parameters, proposal ID, approve, and we're basically returning a response and contract error. Here we are actually, because we have saved our proposals. So now what we're doing is we're actually inheriting or loading these proposals from the storage and actually getting the proposal ID. And once that is, then we're having a mapping error. Basically, that's gonna return as a contract error if there is if anything went wrong. Okay. Then we have proposal log orders, which if it contains, then we're gonna have info sender, and it's gonna return a error. Okay. That is gonna say basically, okay, if it contains, that means that member has already executed. Then we have two options right here. Once we have checked this out, we're gonna have two options. If approved, then obviously the votes for is gonna be increased. Really basic stuff. We're gonna increase the votes for. And other thing, we're gonna say that proposal dot votes against. Okay, then we're gonna just basically insert these proposals, and we're just going to be inserting these proposals, and we're just going to be giving out the info.sender. And once we are done with these things, and then we can go ahead and just save the function. I mean, just save the proposal into the depth storage, the proposal ID, and just the proposal that we have right here. And yeah, we have like we're gonna be firing up this event. Same as I told you, this event is going to be a vote thing. As I showed you right here, it's gonna be returning a value of vote, and we have another attribute of proposal ID and string. And yes, guys, this is you guys can see other things as well. So we have query get proposals. I can just send you the link. Please clone the repo. Once you clone the repo, you gotta understand what's going on. And yeah, this is basically what that contract means, guys. I want you guys to see the front end and back end. That's where the interesting part is. I don't want this thing to be really uh time. I mean, I know it's a little bit complex. I do understand, but now John can explain you what's going on with the front end and back end side. And yeah, guys, if you guys have any questions regarding this contract, please ping us, and I can definitely can help you with that. So any questions regarding anything, John, Russ contracts? I don't think so, right?
I do not see any questions right now. I see someone's excited to create a Coreum community DAO, which I agree with. That would be super cool.
Yes, that's what the goal is, guys. The goal is to create this DAO where basically now you guys can have a community DAO where you guys can vote on proposals. You can have your own proposals where you can basically vote, and anything. It depends. You can have like, okay, let's do a workshop next week on something, So yeah, like I'm excited for this workshop, and we're gonna be having this production code later on. And yeah, excited for this. Excited for it, guys. So yeah, guys, that was all the workshop about. So now John will be explaining you other stuff.
Nice. Sweet, sweet, sweet. Okay, so let's get started. Jay, can you see my screen on the feed?
Uh, yes, if you can just maximize it, please, that would be awesome. Thank you.
Sure. Yep. All right, guys. So let's get started. So the first thing I want to do, and again, this will all be available to you. The first thing I want to do is I want to just take you through a walkthrough of what this DAO looks like, right? So this is our front end. So the first thing we're going to do is connect our wallet. And as you can see, my wallet address is shown right here. Welcome to Coreum Testnet DAO. Now, in order to interact with this DAO, you're going to need funds. So we set up a nice little kind of funds link where you can link directly to our website and just get the funds you need. You paste in your wallet right here, and then you can get and then you can just like request funds. It's pretty easy, but that's so if you want to interact with this when we have it live, you can just simply do that. So now let's go to the proposal, and let's just kind of make a quick proposal right now. And I'm going to make a proposal for a DAO workshop. We'll just call it DAO workshop, and then I will type in maybe like a workshop on how to build Cosm Wasm DAO contracts. Okay, and now I will submit my proposal, and I will sign with my wallet. And let's go to the Block Explorer, and we can kind of test to see that I just did this. If we refresh, and we have our contract pasted in here so we can kind of see. And as you can see, my transaction for this proposal went through about 12 seconds ago. And yeah, here we have it on chain right now. We have our DAO workshop building Cosm Wasm smart contracts. So, okay, so it works. And now let's go back to our page right here. And let's go, we'll just go back and we'll go to vote. So now you can see my proposal is up there and it's being pulled right from the chain. And I'll show you how we do that in a bit. But yeah, a workshop on how to build Cosm Wasm smart contracts. We have for, we have against. I'm going to submit a vote, and and this is block time essentially. So this is what Jay was explaining a moment ago. This is, essentially a way that we time the votes. So, 2 minutes. And I'm going to get into that a little bit later after the workshop because I kind of want to give you guys an exercise, and we'll talk about that later. But okay, so I'm going to submit my vote, and it's proposal number 0. So I'm going to type in 0, and I'm going to say I want no. well, I said yes before, so we'll do no this time. And I'll approve. Okay. And we'll check Block Explorer, and we'll see if that went through. All right. And it looks like our no vote went through. We voted. We said false. And now we're just going to refresh real quick. And we have a little notification there. Oh, I have to connect again. And you can see now we have our no vote. It went through. And yeah, so we voted against this. Okay, so now let's kind of talk about the code a little bit now that we did a demo of what's going on.
John,
And
can you also
sure.
show the query proposals if that's on the console side?
Yes, I will do that. So we set up these. So for testing purposes, we set up these two functions where you can just easily query the blockchain, to kind of see, or query the contract to kind of see the proposals. So I'm going to inspect and just show you what this looks like real quick. So if we go into the if we click query all proposals, you'll see right here that we get our query response. And again, this is directly from the chain. I'm going to show you how we do this. And yeah, you can see we have a bunch of fields here. We have ID number 0, which is the ID of our proposal. It's the 0 number proposal, the first proposal. We have title, DAO workshop. We have description. And then also, if you go into here, you can see we have even more fields. And if you were looking when Jay was kind of showing the contract, or if you're just arriving, Jay was going through all the various things, all the various fields that we add to a proposal, right? So the interesting thing right here is we have voters, which is my address, right? I'm the only one who's voted. We have executed, false. But the interesting thing right here is voting end, right? So keep that in mind, because that's going to be kind of like our little exercise at the end here. All right. And you can also query a proposal by ID. So if we type in 0 and we query the proposal, you'll see that down here we get ID number 0, which is, again, the same proposal that we just put in. All right. So let's kind of jump into the code a little bit for a minute. Does anybody have any questions? Okay, cool. All right. So let's jump into the code. We'll get rid of this screen right here, and we'll pull up my DAO kind of repo. All right, so the first thing that I think we should go over when talking about connecting a dApp to the blockchain or to Coreum blockchain or any blockchain really is making our app enabled to receive signatures and transactions, right? And we need to essentially set up what's called a signing client. Okay, so you'll see right here we have our app. This is kind of like the main file that our React app is kind of based around, this app TSX. And you'll see that we've wrapped the entire app in this signing client provider, which we're getting from context client, which I'll show you what that is in a minute. That's basically a context that we created so that we can share this signing client across all of our components in the app without having to use a backend or anything like that. We use something called use context for that. So basically what we're going to do right here is I'm just going to show you the basic layout. So we have a couple components right here, right, for our app. In addition to this signing client provider, we also have layout, which is right here. And our layout basically covers, if you go back to our UI, our layout basically covers these things right here, right? We have the heading, and then we have this kind of bottom tab right here. And that's basically what we're defining in our layout, right? So we have our heading right up there, and then we have this nav tab as well, which is the bottom part of our app. And we'll get into the heading in a minute. That's kind of where we are able to sign transactions. That's where our Wallet Connect is. Okay, so let's go back to our app file, app.tsx, and let's talk a little bit about this signing client provider that we're exporting from context clients, okay? So here we've basically set up the signing client provider to the value of client context. And we do this by using use client context, which we kind of define right here, right? And you can see we have this struct, and it has a bunch of different variables, right? And we take a wallet address, we have the signing client, we have Coreum query client. We're only really going to be using these two things. We're not going to be using Coreum query client, and we're going to be using connect wallet and disconnect wallet. And the way we define these is in this kind of hook section, which I'll show you later, which we're kind of importing these things from. Excuse me. So here kind of we have the context. Now in React programming, create context is kind of a tool that we can use to easily share data across many different components in our application, right? And we're getting it from our React components right there. So essentially we're exporting the context as, use signing client. And since we'll be using the signing client in many parts of our app, which I'll show you later, we kind of want to create this context for it so we can use it everywhere without relying on some sort of database, as I said before. So what you're seeing right now, again, is really just kind of the structure of that. And if you look right here, by kind of defining this, we set up this signing client provider, which we wrapped our app in for app TSX. Okay, so let's go into the hook section. And this is really kind of where the meat of all these definitions come from that I showed you earlier. So the first thing you'll see here is the interface that we kind of established in this other context client script right there. Okay, so we have this interface set up, and that's kind of how we're going to define all of our stuff. And we basically have this giant function right here, which sets all of these variables up. Okay. Jay, do we have any questions so far or no? Okay. So there's a lot of stuff that we're importing here. Okay. If we go up, we can see kind of like all the imports. Um, but let's just take it step by step because there's essentially, yeah, again, there's like one big function that's going to define all the variables and make up this context that we're trying to create. So specifically, let's focus on our wallet address and the ability to create transactions with the COSM WASM, uh, you know, create transactions to the COSM WASM contract. All right. And we want, again, we want to make it easy by doing it all from one script. So going to focus primarily on this import right here, this signing COSM WASM client, which we're getting from Cosmos.js, COSM WASM Stargate, right? And Stargate is a COSM.js library that allows us to easily interact with, COSM WASM contracts. So we're pulling this signing client from there, and they kind of have it set up for us so that we can easily kind of make signatures to this contract. And the other thing I want you to focus on too is this connect Kepler um, uh, variable that we're pulling from our services. If we go down here, we've kind of set up this script to easily allow us to kind of like work with Kepler Wallet. And we have a number of things in here like, defining, specific, gas transactions and things like that, kind of optimizing the Kepler Wallet. But basically, those are the two things I want you to focus on the most in these hooks when we're kind of importing, because those are the things we're going to be using the most. Okay, so okay, so now let's go down and kind of look at these kind of .env endpoints right here as well. Okay, we're going to take these. Basically, we need these so that we can properly set up our signing client, right? And all this is, if we go into this .env file, you can see that we have all these variables set up, next public chain ID, and these are all kind of enabling us to easily connect to the Coreum testnet, right? So these variables you'll have access to and you'll be able to set them up. Of course, they're already set up in the repo that you'll be downloading. But yeah, this is essentially, all the kind of different things that you need to connect to Coreum testnet, and especially this RPC node right here, which you'll see later. We have to use that for something else. Okay. So let's go back to our clients. Let's go in here to this function. So the first thing that we're going to do is we're going to connect to our wallet. We're going to connect to our Kepler wallet. And basically, when we do that, it'll pass in our Coreum chain, which again is defined by those .env variables. In this case, I already explained that. And this is essentially how we also define our offline signer. And so it's essentially an instance of Kepler Wallet that's been hooked up to Coreum. That's the best way you can think of an offline signer. And if we go to the bottom where it says set wallet, you can see that basically that's where we're getting our wallet address from, right? If we just go to the bottom here, let me look right here. Set wallet address, and you can see that we're actually getting that from the offline signer. We're able to kind of get accounts so we can get the current address that we're using. And that's kind of how we set our current wallet address, right? And now let's kind of get to this main integration in terms of the signing client, right? And that's basically setting up the signing COSM WASM client that I explained earlier. Okay. And to set this one up, we kind of need three things. First, we need our RPC endpoint for Coreum testnet, which which I explained earlier. That's kind of like the node that we need to connect to that allows us to hook up. Then we need the offline signer, which we defined. And finally, we're going to need to pass in our gas calculation, which is, the cost of signing transactions. And we kind of have set a standard rate of, I think, 0.6, which is set up in this. If we go back to the .env, you can see that we kind of set that up right there in UT test core. And yeah, so we've kind of set that up. And the other thing we're doing is we're kind of getting this gas price from string. So so basically we're importing this from up here. Again, this is being imported from Cosm.js Stargate. And that just easily makes it so that we can convert this into something that's readable as gas, essentially. And that's all we really need to set up this signing Cosm Wasm client. And basically that's it. I mean, there's more here, but in terms of just setting up the app's ability to integrate, that's pretty much all we need. And if we go back to our client context file right here, we've basically set all these variables up properly by running that function, right? And it's kind of this giant context struct that we'll be mostly using as this right here, right? We're exporting use signing client, and we're going to be exporting this all over the place. So that's basically how we've set up our our repo here, so we can start signing, right? Now let's go to the nav section, which I kind of explained earlier. And the easiest example of how we're using this signing client is just by going to the nav section and seeing, how we have it set up right here. We've kind of taken the disconnect function, which I explained earlier, the connect wallet function, and our wallet address. And this is basically how we're easily able to kind of handle the connect, the connection to our wallet, which is defined in this handle connect thing right here. So yeah, so that's kind of an easy example of how we are using the signing client. Okay, so let's just quickly talk about how this application works, and I won't get into too much detail, but basically, if you look into this wallet loader right here, this essentially allows us to switch between what screen you see, right? So if you remember at my interface, when we signed in with the wallet, we saw a different screen um, than when we sign out. And that's what this wallet loader does. Once we are connected with our wallet, essentially, this will allow us to view the index panel with all of those page links, right? So you can see that we've wrapped the main body of our index, which is essentially kind of like our core set where most of our pages are. Excuse me 1 minute. Jay, do we have any questions so far? Okay. Okay, yeah. So once we've signed in, this wallet loader will essentially allow us to view what you see right now with all these kind of pages, and you can see that we have links to these pages as well. Okay, so yeah, so just a kind of a brief explanation of how that works. So now let's just get into the meat of the application, all right, which is basically these 3 pages right here. We have propose, we have results, which I'll talk about later, and then we have vote. All right, so let's start off with propose. So the first thing we're going to do is kind of import our signing client, right, as we discussed before. And we're also going to import this data structure from Cosmos Amino, or that basically allows us to, easily calculate gas, or, structure the gas transactions. And we'll also set a variable to our contract address and define, yes. Yeah, so we'll set a variable to our contract address, and then we'll define this STD fee, which we imported from Cosm.js Amino. Now we have some logic in here from useEffect that kind of double checks that we do indeed have the address and the signing client set up. And you could put like a loading graphic here if you wanted, right now it's just an error message. But yeah, and now let's kind of go down here to where our UI code is. And you can see kind of how our front end is interacting, right? And we have a form input set up that essentially takes text, specifically the title and description. And when the value is changed in the text fields, right, with this kind of on change event right there, we kind of set these the title and description with these use state variables that we've defined up here, right? So we set the title, we set the description, and that's kind of how we get those variables set up. Then if we go down to the button that we've defined right here. And, you can do this with forms. We have type submit. So basically, when the button is pushed, it'll trigger the form submit functionality, which we'll call our handler function. And the handler function, if we go up here, we have it defined right here. It's called handle submit. And this is where we kind of put in our title and description variables, defined in those use states, to our propose function. And the propose function is, again, this is like the real meat of the application. And I'm going to show you this in a bit. And Jay talked about it a little bit. But yeah, so basically, this is the function where we connect with our Rust contract. Most of it comes down to this execute message that you're seeing right here. Okay. And within this struct called propose, we have two parameters that take the title, which is defined as a string. And it's very important that we define it as a string because it has to be exact types when you're feeding it into a smart contract. And the description, again, is also defined as a string. And, unlike EVM, if you're familiar with that, with ethers and everything like that, you don't have an ABI, right? We interact directly with the Rust contract and WebAssembly. So it's a little easier. And I'm just going to pull up the WASM contract real quick, and I'm going to show you basically how we get this title and description and propose. And again, Jay talked about this a little bit. But yes, so if you kind of, and you can kind of go up here. And you can see that basically we can get propose, title, description, recipient amount. And, these two things are our inputs. And if you go into our make file, I'm not sure I have that up, but if you go into the make file, you'd be able to see exactly how that's defined. Yes. So, yes. I'm trying to find it. I don't think I can pull it up right away. But yeah, so basically, once we've defined the title and description right there and the fields, we can kind of interact with our signing client, which we imported. And we have this kind of Boolean right there, which checks to see if the signing client is there. If it is, we can run this execute function with the wallet address we imported, the contract address, the execute message, and the fee, which we defined earlier up there. All right. Are there any questions? Jay, is there anything you want to add? Yeah. Yeah. So the only other section I'm going to cover, and the final thing I want to demonstrate, is the voting page. So if we go up to the voting page, it's a lot like our proposal page, right? And I kind of want to demo this because it's a little different from how we set up the signing client, because in this page, we're also going to make queries to the blockchain. And I'm going to introduce you to a new module called the Cosm Wasm client, which we're also getting from Stargate, Cosm.js. And we're going to be using this specifically to query proposals from the blockchain, right? So let's set up a few variables, right? And the important variables to look at are vote ID and set vote ID, right? And this is how we're going to get our ID. We're going to also set the vote as well. And that's kind of like the true or false statement. And then we're also going to, well, I don't think oh yeah, we do need set proposal because we're going to be using this to kind of map out the proposal features on our UI, which you'll see how we do that. And then we're going to have the CW client and set CW client, which is the COSM-WASM client. Okay. So the first thing I want to do is set up our COSM-WASM client, and I want to do that as soon as the page loads. So basically for that, we're going to be using a use effect. And yeah, we're going to use this to kind of initialize the client. And the client is kind of initialized with this function right here. So we await the COSM-WASM client. We connect by using our RPC endpoint. And we have this in our .env, as you saw earlier, but I just wanted to kind of hard code it right here for simplicity's sake. And we're going to set this CW client once it's initialized. And that's all we have to do. So it's a lot easier to set the COSM-WASM querying client up than it is to set up the signing client that we set up before with that whole complex user context. Okay, so now let's see if you were kind of curious about this signing client function that you see down here. This just essentially gets the balance. So if you go to the voting page, what this essentially does is it checks to see if we have the signing client set up. If we do, we can get the balance, which is like an automatic function connected to that client. And all we need for that is like our wallet address, and I'll just show you what that looks like right here. So if we go to the voting page, yeah, you can see that I have 187 test score, which is absolutely correct. I do have that. So yeah, so if you were just curious about that, that's what that is. And we're also going to do another use effect function right down here to basically query proposals. So that function I demonstrated earlier where we query all proposals, we want to do that right when we load the page. So essentially, that's how we're getting the proposal to come up immediately when you go to the voting tab. Okay, so now let's start at the top and go down. These are basically the three core functions that we define. We have two querying functions, and then we have another function that's using the signing client to basically execute a transaction in those COSM-WASM contracts. So let's just take this step by step. So first, we're going to talk about it's kind of similar to the propose function a little bit, but if we kind of yeah, so basically we have our query proposal function. We're just going to check to see if our client is there, or else we're going to return. And then we're basically going to query the message. And again, this is similar to the proposal function where we have those, those endpoints in the Rust contract that we have to get exactly right. And I'll kind of show you what that looks like in the contract. So let's just pull up the contract quickly, and let's go to this kind of public function query, and you can see that we are getting this kind of empty parameters for list proposal right there. And yeah, so this is essentially kind of how we can do query all proposals. We have list proposals, and that's basically, what we got right there. So yeah, so again, it's similar to how we do it with the proposed contract, but it's it's a little more simple, as you'll see here in a minute, because all we have to do to query the contract is pass through a contract address and the query message, and that's it. We don't need a signer, we don't need gas, we don't need anything. That's all we have to do. So it's really simple. Now we get a response, and if the response checks out, we set the response in that set proposals use state variable that we set up earlier. And this is kind of an example of what we're going to do. So for each proposal, we're going to console.log all the different features of that proposal, right? So we're going to get the proposal ID, the proposal title, description, and so on. Votes for, votes against. And that's essentially how we query all proposals. And that's set up on this tab right here that I showed you earlier, where you can vote on all proposals, right? That's how we get that. So query one proposal is kind of the same thing. We pass in this proposal ID, which you saw earlier on the UI. That's just an integer. We pass that in. we query the message, and we make sure we get these messages, this execute message, or this message exactly right, according to the smart contract. And then very similar, we get our response, and that's how we query one proposal. And then the last thing I want to cover is this voted function. And if we go down here, we can see that, this is kind of how, well, before we get into the voted function, I just want to kind of show you how we're mapping our proposals onto our UI. So right in here, this is where we have our on-chain proposals, which are displayed on the UI. We have our proposals, we map it out. And for each proposal, again, this P, each proposal, we do the ID, we do the title, we do the description, and that's how we get that. And then time till end. Okay, so we're almost done. I just briefly want to talk about, how we're going to interact with our UI, and it's very similar to how we did it with the proposals. We have a form, we have a single function called handle vote submit, and then the first field of this form, we take a number, right, and that's going to be the proposal ID, and then the second field, we're going to take a yes or no response, which we're later going to convert to a Boolean. Okay, so if we go up to our handle vote submit function right here, we have an error check if vote ID, alert, please fill in all fields. So basically, if you're not filling in all fields, it's gonna get this error response. You have to fill in all fields before you can hit the submit button on this form. We're going to convert our vote, and again, our vote is this variable that we set up here. It's a string. We're going to convert that to a Boolean, and then after that, we're going to basically take our voted function, which is the function that executes the vote message on chain. We're going to take that function, we're going to pass in the vote ID, and we're going to pass in this Boolean right there. And then we're going to send an alert when we do it. So real quickly, I'll cover this real quick. Let's get into our voted function. Okay, so as you can see, we pass in the proposal ID, we pass in the Boolean, we check to see if if we have a wallet address. If it's empty, we return. So this function's not going to pass. And then we try to execute this message. And before we execute it, we have to make sure that we're passing in the right fields, right? So I had to convert this into an integer in order to basically pass in the correct field that this contract takes. It takes an integer and it takes a Boolean. And this is very important for the execute message. It has to be the exact types, or else you're going to get a type invalid error. And then, basically after that, we await the signing client. And again, I explain the signing client. It has this execute function. We check to see if it's, active. And then we execute the same message that we did for propose with our wallet address, our contract address, execute message, and fee. And that's basically it. That's basically the entire DAO workshop. And that's essentially how it works. Now, what I think would be a cool exercise is if we go into this results tab right here, and I'll show you this in a minute. Basically, we have these proposals, right? Now, these are not being fetched on chain, but what I think would be a really cool exercise is if we're able to basically grab the results of the proposals and fetch them and display them kind of like we did for the votes right here in the results tab. And the way we're going to do that, right, if we go back to votes right here and we do query all proposals and we inspect, right, the way we're going to do that, let's do that right there, is by basically looking at this voting end time and figuring out how can we display the proposals in results that have expired. So I think that would be kind of like a cool thing to do as like a next step. Maybe if you download this repo and set that up, you can watch this workshop and figure out how to do that. That would be really neat. We're going to do it anyway, and you're going to have full access to this entire repo. You're going to have full access to a link, a Versa link that we're going to set up. And we're going to, we want to set this up so you guys can vote on workshops just like us, or just like we did in this demo. And that's about it. That's the, Jay, do you have anything to add? We're good to go. Thank you, guys.